Okay, this is Dr. Williamson doing part 3. So to calculate the enthalpy of reaction using the enthalpies of formation for the first reaction, we would take the first reaction and you write down the enthalpy of formation for first reaction from, what was it, Appendix B, and I wrote them down on top. And then the enthalpy of the reaction will be the enthalpies of formation, products minus reactants. And for this one, I got negative 496.0 minus these zeros, I get 496.1. Oh, excuse me, 469, typo here. 461.9. 461.9. So I need to change this. Negative 461.9. So I get for going too fast. 0.9 kilojoules per mole. Do the same thing for this reaction, and I get negative 153.1 kilojoules per mole. Then in the instructions, it said I need to take the get the enthalpy of formation of water, and that is this reaction right here. And the enthalpy of reaction for this is negative 285.1 kilojoules per mole. Then I want to use Hess's law to add up these reactions in such a way that I get this reaction to get the enthalpy of reaction for the formation of magnesium oxide. I can do that if I switch this reaction around and reverse this reaction. If I reverse this reaction, I get this reaction right here. So what I'm going to do is I'm going to take this and I'm going to delete these guys. And I'm going to put this in its place. Okay. And then you'll see, if I clean this up a little bit, cleaning up, cleaning up, cleaning up. You'll see that if I add all of these together, that Mg2 plus will cancel with Mg2 plus. The 2H plus will cancel with the 2H plus. The H2O will cancel with the H2O. The H2 will cancel with the H2. And I'll be left with magnesium solid plus 1/2 of O2 will give me magnesium oxide, which is exactly this reaction. That means the enthalpy of this reaction, delta H, of this reaction will be equal to delta H of reaction 1 plus the opposite sign of delta H of reaction 2. Why the opposite sign? Because we swapped the chemical equation. We reversed the chemical equation, and when you reverse the chemical equation, you swap the sign of the heat. Plus the enthalpy of reaction for the third equation. And that's going to be, it'll just be easier for me now if I type it in format, type. That'll be negative 461.9 plus. Now this guy, hold on for 1 second. Let me change something here. I forgot that I have to change the sign on this to be positive. There. So this is going to be negative 461.9 plus positive 153.1 plus negative 285.1. When I do my math, I'm going to have 153.1 minus 461.9 minus 285.1 equals that negative 593.9, whoops, negative kilojoules per mole. And I think that's right. Okay. Move this back down and assume the equal sign. And then it's put it here, equals. And I believe that's the answer, guys. Okay. Hopefully you'll double check it and let me know. I hope that helps. That's not all of part 3, but a big chunk of part 3. Okay, then I hope that helps.